Tyler.
Hey, what's up, man?
Just a little bit of everything. Dude, we got some great feedback on we've been getting great feedback in general on, like, I feel like we've had a great run
Of
of
what?
podcast.
Oh, podcasts.
I
I don't know what you're
really,
talking about. If
I
you're talking about
really,
shirts or
yeah.
pencils
We've
or
got we have gotten some great feedback for the last dozen or so podcasts. I feel like we're on a streak. Knock on wood. I don't want to ruin it here, which we're not. But I feel like the audience is really engaged in a lot of the conversations we've had, which is awesome. And we've said it before. That's what fuels this podcast. You guys providing feedback, being on Instagram, sharing it. I'm reading the comments on some of the clips. Today I read the Joppa group was like, "Hey, I really need to hear this today," and it was a clip. I'm not even sure what it was a clip about. It was something I think I was probably complaining about because that's what I usually do on a podcast.
I
But
thought
I'm
I
I
was
re-
a complainer.
well, I think isn't that what
Both.
guys do? Is we just start podcasts and complain about crap. But reading that, it's like, yeah, I'm glad. I'm glad we do this and appreciate everyone supporting us. And speaking of supporting us, one of our sponsors, Andersen Windows. We got Brandon on from the Research and Development Center at Andersen. He's the guy that has the special access to the roof that we are
Yep.
not allowed on.
Wish we had
But
had that connection when we went out there.
no, no, you know what? I think it was a planned attempt to prevent us up on the roof. If you guys
Yeah.
don't know what we're talking about, head over to the Modern Craftsman YouTube channel. We actually filmed a bunch of videos from our visit at Andersen Windows Factory in Minnesota. That was amazing. But today we're going to talk about talk with Brandon about research and development and his background in that industry, but also how it relates to the building industry as a whole.
Yeah, I think that a lot of people don't realize what it takes to put this stuff to market and how much testing and research and innovation goes into their products. And it's we've experienced it and saw it and witnessed it firsthand. And we'll have an hour or so that you can listen to Brandon's perspective of that and how he manages that across the whole company. So I hope you guys enjoy this one. Obviously, thank you to Andersen Windows for the guest, for the sponsorship, for the partnership, and for all the help. We'd be hard pressed to do this without you guys, so we appreciate it. How are you? Good?
Yeah, it's good. It's cold. There's a little bit of snow on the ground, and getting close to the holiday season, so things are good.
Nice.
Do you guys shut down at all? As like, I mean,
Just
it's such a big operation to shut down.
yeah, Christmas Eve and Christmas Day will be down,
Yeah,
but otherwise we'll keep running for most of the time. Yeah.
yeah. I mean, after touring, like, if you guys haven't seen the video, we posted the video on our YouTube. But after touring the facility, I'm imagining shutting everything off for 2 days must be
Yeah.
like a 4-hour ordeal.
Yeah. 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 I saw the video. You guys were you came through this building here in R&D,
Yep.
and then I saw you guys were in the window plant and the door plant. So yeah, I really liked your. It was fun. It's always good to get outside perspective on when they walk in and see some of the operations and the way that the way we put the product together, all those different things. And so I thought it was. You guys have clearly been in the industry for a while, and you've clearly been in some other factories because you picked up on things that pretty insightful. So yeah, that's good.
You know what? I don't even know. I don't know if I could take credit for that because I feel like you guys have it organized in a way that it's huge, right? Like you're not walking the facility, but as you're driving, and I mean, we had obviously a tour guide, but as you're following the tour, it's pretty self-explanatory. Like the material comes in raw, and it goes through a bunch of moments
Yeah.
and then out the other end gets spit out a window. So I mean, maybe it's the product of a great tour guide or a well thought out factory, and I would argue that it's probably both. But that truly was the most interesting thing, is that there's so much going on, but it's very clear that each step is attributing to what that end result is.
Hmm.
Not like nothing seems out of place, I guess is
Yeah.
what I'm getting at.
Yeah. Well, that's the I think you guys touched a little bit on the video, but this idea of everything is customized and it's all made to
Mhm.
order. You almost I have to believe a lot of our competitors have designed the same way, but you have to do it that way. Otherwise, you never be able to keep track of all the parts and pieces and bring everything together. And yeah,
Forget all the parts. Like, what about the equipment? Like, some
yeah,
of that equipment wasn't you didn't buy that at a store. That
yeah,
that was a product of someone tinkering with a piece of machinery, a couple serpentine belts, a couple electric motors, and some actuators, and it was like, "Here, this does that."
yeah.
And that I think I asked someone, I was like, "Does anyone have a full, like, list of everything?" I would never wish this, but God forbid, the entire building just disappears one day. Could someone recreate it, or would you be starting from scratch?
Yeah, some of the operations that you saw in Bayport, the vacuum forming and some of those other machines, I don't know that there's another. I don't. I doubt there's another machine like that anywhere in the world, honestly. Um,
Yeah.
and we certainly have things in place to recover if we had to. But yeah, they're really really unique machines, and that's part of the story with our company, right? Is this marrying of the design and the materials, but the process is critical, which is what you guys saw. And actually, there's a lot of things that you saw that we didn't necessarily show you also at the same time.
Mhm.
That is some of the secrets of the way we do things. So
Yeah, we went up on the roof. Remember, Nick?
We
There's like
we
there's one place no one's allowed. It's up on the roof.
did we fly the drone over it, or
No, they wouldn't let us. I think Doug
yeah.
had to like stay away from it.
Yeah.
So,
We were like, "What's
Brent,
up there?" They're like,
yeah.
"Nothing."
yeah,
Brandon, your title is the Senior Vice President of Research, Development, and Innovation for Andersen. You've been there, looks like a little over 10 years. What, from like a 10,000-foot view, what does your job entail?
yeah. So I have responsibility for the company for around designing, developing, and commercializing new products, making improvements to our current products. And a lot of the expansion we're in as a company was it's a lot of it's newer manufacturing, newer product designs, and a lot of that is coming from my team and obviously partnership with our manufacturing and our IT teams. But at the end of the day, it's about products and the design and just the number one thing our team is focused on is making sure that the durability that customers expect from Andersen they are getting every single time that we make one window or one door. That's everything. Everything is about durability and performance for us. And when you saw the R&D tour, you could. I hope. I saw the video. You guys could see that. That's what's all about durability and performance. That's why people buy Andersen and they keep doing that.
Yeah, so going into that tour and thinking, obviously we're walking through production line, the factory and everything else, and I think that most people probably envision Andersen Windows as just this like massive production company where you're just building window units. But when we walked through the R&D and saw some of the testing and the proprietary equipment required to test, it's like you have another or multiple businesses within that business that you need in order to manufacture these windows. And it was impressive going in there thinking it's like, yeah, we're going to see how a window's made, but then to see how much effort and how many people are behind the testing of the equipment and what you're putting out there was insane.
Yeah, it's in the 10 years I've been here. I honestly, I never when I first started here, I didn't understand or appreciate um, that Andersen's really a materials company and an engineering company.
Mm.
And the materials in particular, we we have a significant amount of experience and expertise and we use basically every material that's used today in a window and a door we use and we deploy um, and other companies do the same. But we feel really comfortable when we put aluminum somewhere or fiberglass somewhere or vinyl. We have a really good understanding of why we're doing that, and a really good understanding of how it's going to contribute to the long-term performance of the product. And that is a unique thing that I think that we bring. And that's again one of my roles is to continue to invest in that, and we're continuing to launch new materials, and a lot of them are composites or combinations of these different materials that there's some really unique properties when you bring multiple materials together into one lineal. There's some really interesting things you can do, and that's really one of our big investments as a company, continues to be in our platform around composite technologies. And there's a lot of opportunities still, and other industries are working on this space, and we're looking for how are other people doing this, and try to bring it into the window and door category.
What would you say is the main driver of the innovation for you guys? Is it durability, cost, energy codes, a combination of them?
It's probably a combination. We like to talk a lot about being distinctively Andersen, and distinctively Andersen has a lot of different meanings to it. And one of them is design. So one of the things that I think a lot about is when I walk in a home or a building, I want people to walk in and say they know that's Andersen. And sometimes it's hard to know unless you're a window person, or you guys are in the construction business, but the average consumer doesn't necessarily know. There's opportunities for us to do that. So the design language, or the design, the way that things sound or feel, I mean, there's opportunities there. But the primary investment we're making is in this durability and performance, and we're looking for ways to do it that drives value for consumers. And so, we can make a window that's really, really expensive that lasts a long time, but no one's going to buy it. So it's really more about giving people the value at the right price. I think we do a really nice job of that. And if you just look at, we focus a lot on, as you saw in the R&D, we're not so worried about initial performance. We're worried about what happens at year 5 or year 10, year 15. People tell their neighbors when their product still is lasting that long. They tell them, and that's one of the reasons why we've been so successful over 120 years now as a company.
When you think like specifically about research and development, and developing, as you say, like materials, right? I know you guys don't test to the industry standard. You're testing towards failure. Like, you're finding the failure point, and then obviously comparing that to what is industry, but then seeing how you can improve that. So, for example, like in the video, we shot a 2x4 at a piece of glass, fully expecting it to go through the glass, and it didn't.
Mm-hmm.
I think the first time it barely broke the glass. And for me, like, great, glass doesn't break. So I assume you're pushing that to the limit, as like, okay, well, that was at 100 miles an hour. It's like, what happens if a 2x4 hits it at 160 miles an hour? I guess my question is, when you think about research and development in terms of materials, are you guys, which direction are you working? Are you looking at, hey, this is the material, like, how do we incrementally make it better? Or is there this notion that you would start, it's like, okay, well, if we replace the glass with a steel plate, it's gonna block the 2x4, it's never gonna break. Let's work backwards from a steel plate and figure out what it would take for that material to be translucent and not break as easy as the glass. Wait, like, is there a particular direction that you're working?
Yeah, I'd say we think about it like there's many dimensions to, like, your steel plate is a good example. So that would be probably at the highest performance against a 2x4 hitting it, but the energy performance of that would be terrible.
Right.
And the weight of it would be not very good, so a person couldn't open it. So there's all these variables we're trying to balance at the same time. And that's, again, where innovation in material space breaks those dependencies that are there. So there, like the window that you saw, I can't remember if it was a window or a door that we shot for you from a 2x4. It's likely that consumers are would love to have better energy performance. It's likely that they would like to have even more glass.
Mm-hmm.
And all those things are putting demands on the materials that we're using in our products, everything from how we bring the corners together to the material that we use. And, there's ways to the window that you saw, there are ways to make that window have even more glass and even less sash and less frame. And that's valuable to people. There's ways to make that sash lighter weight so that it's approaching something that any consumer of any age or any strength or any whatever will be able to open it. There's continues to be optimization there, and that's where that material technology really is a benefit for us, because it literally everything is in balance. And I think the steel plate's a really good way to think about that and to come off of that one.
Well, I think it's also, I mean, you hear the common one in the building and renovation industry is like, price, schedule, and quality. You can only pick two. And I've always said it's not. You need to prioritize them. You don't, you can pick price and schedule. That doesn't mean that your quality is now a non-factor. It's just the least of the factors. So it's what you're saying. It's you're
I totally agree
balancing
with
it,
that. Yeah.
right?
Totally
Where it's
agree.
like, hey, I want this done fast, as inexpensive as possible and at a really high quality. It's like impossible. It's like, no, it's possible, but let's prioritize what comes first. And what you're saying, it's, what's interesting is like the sight line has become the thing in the window and door industry. How small can I get, the mullions? It's like, oh, it's 2 inches. I got to find something smaller.
Yeah.
And that's become such a priority. And I guess, that side of it, it's very market driven, right? Like you're driven by the market, you're driven by what a consumer wants out of a window. So you're then doing it, but you're not then saying, okay, well, we can do a 1 inch, we'll make it out of carbon fiber and it will be 10x the cost.
Yeah.
Well, that
Yeah.
doesn't work. It's like,
Yeah.
well, actually, I don't want to spend 10 times the cost. I actually want to, I'm willing to spend 10% more. It's like, well, then you go back to a 2 inch. It's like, nope, that's not good enough either. It's like, how about
Yep.
1.75 inches? It's like,
Yeah.
all right, we can do that.
Yeah, a really good commercial example of that is in Florida. In the last year and a half or so, we launched a new product through our Renewal by Andersen channel that is Fibrix, which you've seen, but it is built for impact resistance and the state of Florida. No one can tell the difference, but it's a different blend and a different composite of Fibrix that withstands that 2x4 smash that you guys saw, where traditional normal Fibrix is not designed for that. It's designed for other parts of the country. And so we've now established a different Fibrix blend that works in Florida and passes. But the cool thing is the product almost looks identical to the one that you buy in the Midwest. And so there's value there in Florida, because most product in Florida, because of the requirements, has a lot less glass, has bigger, stiffer profiles. A lot of the competitors there's a lot of steel and stuff in there to keep the rigidity. We don't have to do that with our new blend of Fibrix. There's value there, and that's an example where we kind of work the balance of the Fibrix development to get there.
So how long does it take? And I understand that it's going to be completely different for every product, but when you guys are integrating new products, new components, new materials, it's not as though you're just like, all right, so we made it, we're going to send it out and put it into production. That being said, you also don't have 15, 20 years to test a product. So are you working from like an engineering perspective where it's like, all right, well, it broke down this amount in X amount of years and we figure it'll last this many more? Like, how are you guys testing a product that you're going to put to market that hasn't had 15 years out in the elements?
Yeah, a lot of the tests that you saw in the Garofalo Center are many of them come off a principle like the automotive industry and the aviation industry uses, which is they test them to failure, like you saw and like you commented on, and then you can, based on the way things fail, you can extrapolate out and make a prediction that says, this product's going to last 25, 30 years in the field. We target in that, roughly in that 50-year range. We want things to last on average 50 years. And, just like any other.
Why is that? Because that seems like a
Uh,
really bad business model.
Yeah,
Like your
it's
your customers every 50 years.
yeah. And when what happens when you make that kind of target, you first of all we have a warranty that's 20 years long for glass and a lot of the parts of our product, and to be able to warranty that product and run a business, by the way, to that, just think about how many units of windows we have in 20 year span that are out in the market. If we have a failure rate, you can do some of the, and we've done a lot of the math. If you have a failure rate that approaches anything remotely close to just even a little amount, it can be really expensive.
Yeah.
Uh, and so that's why we target that 50 year. And there's a curve to that performance. But if we target that 50-year range, we know for that a vast majority of our products are going to last well past 20 years, which is what our warranty is. And people pay for that, and people value that, and that's why the Andersen brand has the durability and performance to it. Now, when I say that, there are certainly decisions we're making that are helping to engineer that value, so consumers, that if you go too far, it could get too expensive on you for sure. To your point, but there's definitely that 50 years kind of how we think about things to try to make them last that long.
Yeah. Do you you touched on it a little bit earlier where I would assume that everything that what you're doing is a balance between energy code, between budget, between design. But how much do you guys have to work with the design team? And I'm not speaking of like more of a engineering design as much as like an aesthetic design to be able to obtain what they want the window to look like, but also balance that with performance. Like, is that a constant struggle between you guys?
Yeah, I think it's the optimization struggle balance, whatever word you want to use, is design, performance, manufacturability, and then installation. Ease of installation, and then probably even service at the very end of it as well. You guys know there's certain systems that are pretty easy to service if you need to, and there's other ones that are not. There are certain products are easier to install, but then if they're easy to install, they may not have all the same performance. So they're all kind of in balance. Again, that we're trying to optimize. But again, I would say the material capabilities and material engineering that we have, we can find ways to optimize and maximize more than one of those at the same time, and that's really where we focus a lot of our innovation and investment efforts on. Is if we get something that's really durable and that's easy to install, that's a big thing for us, and that's a huge win. And so we try to go after things like that. Um, Energy performance is another one. If it's easy to make them perform if you stick a bunch of steel in there, but then the energy is not as good. So we're looking for
Yeah.
ways to do some of both.
So how often are you like with respect to that? How often are you throwing design out the window and bringing in like a new product or a new system or a new material versus altering stuff that you're already using?
Yeah, that's a great question. I would say in the last 20 years, Andersen has come up with brand new product categories: the 100 series line, the A series line, um, and but that's becoming less and less. It's more about making extensions to our current platforms, or we can make material changes to the product, like I mentioned, the renewal channel, without making significant changes to manufacturing, because the manufacturing system is, as you guys saw when you're putting
Yeah.
rectangles together, you can kind of change the material a little bit, and it doesn't really notice. So we're probably spending more time on that and less on total new platforms, with the exception of bigger doors. The bigger door areas, we believe there's still some pretty significant areas that consumers would love to have that no one's offering today, or we certainly aren't offering today, that we could design products that could get into those spaces. But as far as windows go, we have most of the platforms are there. It's more about keeping up with trends by what consumers are looking for, and maybe modifying the materials to try to optimize some of those variables we talked about.
I think that's what I was asking too. or similar to what Tyler just said. It's like modifying something that you have versus starting completely new. And, and the example would be, well, what's the best product in the world for thermal conductivity? It's like, well, whatever that is, like, let's build a window out of it.
Yep.
It's like, okay, well, yeah, it's, $10,000, double hung window, but now we understand what the capability of materials are, and then working backwards from that. And the reason I ask that is, I think, for what we do and when we're building, oftentimes it's a matter of working within constraint, and it's usually budget and time. And there was an example a couple years ago. We were doing a millwork install, and we were reviewing the time that we spent on it, and the install took 3 days instead of two, or something like that. And I had asked the question, I'm like, hey, well, like, why did it take 3 days? Like, what could we have done to do it in two? And they were like, there's just no way. We had to deliver it, we had to carry it up 2 flights of stairs. Like, we basically staged it all one day, and then we had 2 days for install. There was no way to actually be able to accomplish that. I was like, well, if we had hired a moving company and you got set up upstairs for your install, and they were moving the stuff up while you were getting set up, could we have done it in 2 days? It's like, well, maybe. I'm like, if we removed the window out of the front of the building and hired a crane and craned everything in one piece, could you have done it in one day? And they're like, I mean, probably on the side of, like, I'm being an asshole, but like, but we're just being, how do we think about what we can accomplish at any expense, and then work backwards from there? Where it's like, of course, we're not going to rip the front of the building off so we can fit a one-piece cabinet into the spot with a crane on one of the busiest roads in Boston. Of course, we're not going to do that. But if we start in that sense, like, I feel, at least for me, I always go to the extreme and then work backwards, because I feel as though, what is capable, and it allows me to think in a more creative way
Yeah.
to a solution. I think that's what Tyler was getting at. It's like, yeah, you have hundreds of years of experience here and product, and it's developed over time. But when do you get to a point where it's like, just like, let's pretend none of this exists and start from a complete, like, material? Like, let's just start with a brand new material we've never done. Are you guys ever exploring to that level of kind of, I don't know, obsoleteness?
Yeah, absolutely. I would say the way we think about that is, um,
Brandon, I
there's
feel like you just answered that in a way where it's like, yes, but we can't tell you anything about it.
well,
That's on the roof.
I
It's
tried
on the roof.
I'm trying to decide. Maybe I could take you guys up there with the camera here. I would say the way I'd be able to answer that is, we think about what are what are the edges of the laws of physics, right? So
Yeah,
you
right.
mentioned conductivity. Um, you know, an absolute, like, they make vacuum insulated glass today. It's been a known technology out there. That's, from what we can tell, that's probably um, the most viable and limit around
Mhm.
energy performance of a glass system. So
Yep.
that's an example of that. That's a limit. There's a sound. So there's energy. There's sound. There's light
Mhm.
coming through. Um, we
Can
are,
we pause there? The
yeah,
vacuum insulated glass. So
yeah,
I'm not familiar with the glass stuff, but I'm
okay,
familiar with the vacuum insulated panels. And they're for anyone that doesn't know, it's exactly what it sounds like. It's a insulation foam panel or something like that that's vacuum sealed, and a half-inch layer has, like, a ridiculous R value,
yeah,
like insane R value. And Ted Benson, I feel like I'm allowed to say this as I'm saying it out loud. Maybe I feel like he's talked about this on Instagram, but they use it in their doors. So you have this beautiful wood door, and they slide in this little half-inch sheet of, it's called a VIP, I believe, and then it super insulates that door. And we've looked at it. So, but there's two things. Number one, you have to order them exactly to size. You can't cut and fit them because you destroy it.
Yeah, just trim a little off.
Well, yeah,
yeah,
and it's destroyed. And then secondly, they're insanely expensive.
yeah,
And so, you mentioned the glass. Like, So that's a great example of something that, probably the greater population doesn't know about. Do you think a product like that will, especially as we trend towards more and more energy efficient homes, will start becoming more readily available, thus, driving that cost down to
Yeah,
being more obtainable?
I actually do. I think the I think what's the thing or the thing the way I think about technology, the way we think it's there's what are some of the business motivations, right? So if the energy codes continue to go to a higher and higher performing energy, as a window and a door manufacturer, that makes us anxious because uh, people would buy less windows and less doors, and consumers would not be as happy either. By the way, because it wouldn't have as much. So we are motivated to make sure that as energy codes continue to come down, that we are still offering products that give consumers what they want, which is the design uh, agility to do whatever they want for in their design of their home, but also providing more better and better energy performance. So I think that there are certain technologies that yes, they are like prohibitively expensive, but vacuum insulated glass, as an example, is two pieces of glass, which is the same as what we do today. There are if you haven't if people haven't seen those, there's little pillars in there that are spaced to keep the glass, and they vacuum that to a really low vacuum amount, and it's sealed, and the energy performance is incredible. Today, the capacity to make that in the United States is very, very limited, and the
Mhm.
price is very, very high. But fundamentally, the technology is not, with the right business motivation, there's no reason why the technology can't approach similar range to what we buy and purchase glass for today, insulated glass units today. So that's an example of that's approaching the limits of kind of the physics there.
Mhm.
And we're very we're actively working in that space. We're actively working in a sound space. You've maybe seen we're actively working with a startup company out in California. They make um, transparent solar photovoltaics that go on inside the glass that can capture some of the light coming through, not the visible part. It's really hard to see, but it
Mhm.
captures the UV and IR that's coming through in the visible on the light spectrum, and we can convert that into power. That's another one that fundamentally the the physics of that and the chemistry there is not should not be a lot more expensive than what people are buying today. Of course, at the volume it's at today, it is very expensive. But that's how we think about things. Is we look at the basics of the technology, and if we think we can get there based on our knowledge that we know, we try to go all in on those technologies and see how far we can push them.
Are there other window manufacturers who are investing in that same thing, or is that something that would be proprietary to you or just with this company?
The transparent photovoltaic that we're working on with that company, we have exclusive, and that's all public knowledge. We have exclusive partnership with them
Yeah.
for residential United States. There are other technologies that are doing that. They have different levels of transparency, different levels of capability, but the big play there, honestly, is not necessarily residential; it's
Yeah.
commercial. So if you make that on skyscrapers, just your area you're getting there is huge. But this is an example where, as a company, we also uh, we are investing. We believe in it for residential, for applications for our consumers, but we also feel that um, there's a there's a greater good there for Andersen to try to put some investment in some of our expertise into that technology, because that has a huge potential for the country and the world, honestly, from a energy renewable energy standpoint.
So what does that I don't even know if you're allowed to talk about this, but what does that relationship look like at this point? How far along are you? Are you guys right now putting money into this research to help develop these systems, or are you at the point where it's like, let's start integrating these things or figure out how to integrate this into our glass, or what's it look like?
Yeah, some of both. It's funny you mentioned the roof. If you would have been up on the roof of Garofalo, you would have seen that we call it the dog house, but it's more like if you're from an ice house in Minnesota. But it has there's 8 windows up there that have this ubiquitous technology in it, and they're generating power and lighting up lights, and we're testing it. We want to understand if something's facing a north or south or east or west, how much power we can generate with it.
Yeah.
So it's we're this is something that is not. You will not see this from Andersen product in the next year or two, but sometime after that, I would, with the right technology development, some of the right luck, you'll see product from us, in that 2 to 3 year time frame.
That's so fast. It's crazy to think how quickly you guys, and I know that this has something to do with all of your in-house testing and the R&D that you guys own, but to be able to take an idea or a technology or a material and be able to not only design that, but then produce that and then test that and put it out into the market in a matter of a couple years. Like as you're saying that, I figured you're going to say like 10 to 20 years from now. And then you're like, maybe not next year. I'm like, holy crap. That's just so like the turnaround. It's insane.
Yeah, this is an example too. As we think about investment in technologies, there's certain components of the product that are, we use the terms like subcomponents and units. And so the glass itself is a really nice standalone subcomponent of the product that
Yeah.
a lot of testing can go on that thing without ever making a window.
Hmm.
And that's one of the reasons why that's maybe moving a little bit faster for us. Now, I also said there's a little bit of luck and some technology development in there too. But we feel pretty good about where that's at. That one's all about scale. We don't, I don't think in 3 years you're going to see us offering it across a wide span of our product lines, but it might be available in certain products. This is another one that consumers, when we do consumer testing of this product concept, it takes people a while to understand. Well, like what would they actually do with the power? And then once they start realizing, this thing could generate power, then the ideas just start flying at us, and it's pretty cool. So it is one of those things that's not obvious at first, the value that would bring to a consumer.
Yeah. I want to circle back real quickly when you were speaking about energy code and energy efficiency and basically what you guys are bound to. Do you like as far as the products that you put out, even if it would be to like a triple pane glass, what is like the highest R value that those units could have?
Uh,
I'm not going to hold you to like
yeah,
a
in the
decimal
window
point.
business, we think U factor, which is the reciprocal of that. So the U factor for a full unit that's triple pane, we can get down to 0.2 pretty consistently.
I wonder if I could figure out. I'm going to look it up. Um, like a U factor to R factor conversion.
Divide 1 by the U value.
Yes.
I guess what I'm getting at here is that is there, and it's somewhat of a double-edged sword, right? Where they want you to produce these units that are so efficient, but at the same time juxtaposed to a wall assembly where they're requiring whatever R value in that wall, they're just not competing with that. So is there any world where they're going to start limiting the amount of glass that can go in a building as a whole? And obviously that's concerning for you because it's like, well, we don't have to make our units as energy efficient, but now we're selling less units as a whole. Is that anything that you guys face?
Well, for sure. Yeah. And there are certain states that even in the current stretch energy codes and things, that's one of the variables. They are using things like, square footage of windows per square footage of floor space, those kinds of things, and are limiting that. I think that's a concern for us and a concern for builders and designers. Consumers want the glass. They want to be able to look. They want to be able to look out and the indoor, outdoor living. I mean, there's definitely a lot of motivation there to continue to push that performance of energy for our products, and that absolutely is a concern of us and in our entire industry, frankly. What is interesting is like triple pane. We offer that today in a couple of our products, and we just don't get a lot of demand for it.
Yeah.
And it's coming. And there are certain design considerations that you have to focus on there. But we're happy to sell that. It just we don't get a lot of demand for that type of level yet.
Is just because of a price standpoint, or nobody's even planting that seed within like the design or from like a builder's perspective?
think it's some of both. I think the builders,
Mm.
there's some of both. There are certain actually out in the Northeast, um, there's there's requirements obviously that you guys are very familiar with around how to, different the whole house you're trying to hit. And I think there's a recognition that there's maybe other ways to get there from a whole house than a triple pane. And again, that trend's going to change. We know that's going to change, and we're
Yeah.
happy to be there to do that. And one of the reasons why we're investing in it, back to ubiquitous real quick, is that we also would like to look at it more of a total energy. And if there's ways for us to offset energy efficiency with some energy generation, we like that as an approach. And the third angle of that is to bring in durability as well. We are, as you saw, we are focused on making sure that air performance, as an example, is performing at year 10 or year 15, very similar to what it was when you first installed it. And over time, that energy loss is significant. So
As far as leakage goes, yeah.
as leakage, yeah.
So
So we're
that's
really,
more so gaskets and everything, and
yep,
not the glass. So I mean, even there's the right where it's like if you have triple claim pane versus double pane, the leakage is the gaskets and everything else. So it's like, why upgrade and spend all of that money when it's still a lesser insulative material than the wall assembly that's next to it, and you still have issues with the gaskets and everything else 10-15 years down the road. I
yeah,
understand the
absolutely,
argument completely. um I think even we don't do it near us, but Nick, you guys have like tests for leakage in a building.
Hmm.
And that's not necessarily testing for any sort of R value or insulation, as far as just how airtight the house is, and what pane of glass you have in there isn't necessarily making a difference.
yeah. I think our ideal solution there, like when you guys talked about kind of the limits, and we would love to see triple pane, maybe vacuum insulated glass someday. That's your energy,
Hmm.
um, an energy generation of some kind.
Yeah.
We like the transparent photovoltaic, and then the third part of that is that durability. And we, back to the material thing we talked about. One of the uh, most significant things we're focused on in our R&D center here is the movement of materials. Materials are moving in cold climates and hot climates, and every time they move, they create or they close a gap. And that's over time, that is really hard to design to. And so you see things like I know you guys saw, instead of 4 pieces of weather strip, we have 1 piece of weather strip.
Yeah.
It's things like that make a huge difference. And so if you take, really high energy efficient glass of energy generation, and you add this durability component and performance over time, and I'm not talking over 1 year, but like 10, 15 years, all three of
Hmm.
those things together, um, that's the Andersen. That's where we're going as a company, because it's all three of those together are really truly the energy performance of a building. And that's if you think about the direction we're pushing to the limits, that's where we're going, is those 3 areas.
Well, yeah, because you guys are going to produce a handful of products that are targeted to geographic areas or specific climates. But when you look at the big picture, a lot of your product lines have to be installed at the extreme, like polar opposite of the
Yeah,
spectrum, where it's freezing cold or hot all the time. And how do you create a product or a product line that fits that bill, while not necessarily just designing to like the tightest stringent determining factor there, where it's like you still have to make money, you still have to come into the market at a certain price point, but then you still have to perform at both opposite ends of the spectrum. It definitely makes your job a little
yeah,
bit more
yeah.
difficult.
I'm laughing because even just this morning, the business team. One of our products is primarily focused in the Southwest, which is not. There's no cold. There's no, and they all when anytime anyone says, "Oh, we never want to offer that in the Northeast or the Midwest," I always laugh because they will want to, and so we have to figure out a way to design it so that it can perform in all these different locations. Actually, one of the worst weather places that we try to model off is Bismarck, North Dakota. When you
Hmm.
look at the extreme cold and the extreme heat that they get in that city, if we can have products that can perform through both cycles, we're feeling pretty good about our performance.
Yeah, I mean, you look at it with automobiles, motorcycles, and everything else. It's like half the time these companies that are putting stuff out to multiple countries, they're not necessarily making different models. Like they're building to certain tolerances, and then that's getting shipped everywhere because it's like we can't produce a specific window for each different region. Like it has to fit the mark that it can be installed all over the country. And I'm sure that that presents a lot of challenges for you, especially coming to market at like a competitive price point.
Yeah. Yep. Another one of those trade-offs, those balances for sure. Yeah.
Yeah, I'm sure. Well, the one good thing that you have going for you there is everyone has to hit those same targets to at least some extent. But what before you were with Andersen, were you like what's your background?
Yeah. So I have a chemical engineer degree from University of Minnesota, and then I spent about 14 years at 3M company here in St. Paul, and a lot of
What
manufacturing, R&D manufacturing kind of background, some of both. Um,
what made you study that?
Chemical engineering was the combination of physics and chemistry. That's just something I always. The physics part of it's so interesting, just because it's so real. Um, growing up working on cars and doing my own things, that's a physics part, and then the chemistry. I don't know what it is about chemistry. You don't really see it all the time, but it's there, and just that
Mhm.
combination, it was just what kind of drove me to. Um, Physics and chemistry is kind of the core of chemical engineering. Um,
At what point did you realize that it was so heavily math based? And did you regret your decision?
oh my gosh, yeah, like right away. Yeah, it's a necessary evil, but I just don't. Yeah, I don't necessarily geek out on the math part of it, but it's necessary. Like you have to that's kind of the foundation, of course. But
It
I didn't realize that I was a bio major initially, and then I start like getting more deeply involved with chemistry and obviously physics, but even like chemistry. And I'm like, I'm supposed to be a science major, and
mhm.
all I'm doing is
it's
math. And I
math,
was
yeah.
like, I did not think that this. I had no idea. Where all of a sudden I'm like, do I really want to have a background in science? And then I ended up dropping out.
I remember, so we took in college I had physics and physics 2 or something like that. And I remember my freshman year I flunked out of physics. And the labs I would crush, but I could like the moment it was back to the book, I couldn't do it.
Yeah.
And I remember he was like, "Hey, we're going to send you back to a math class like next semester just to like so you're more prepared. Obviously, like whatever, like basically like you're an idiot, like you should know this stuff, but here, go backwards." And it was literally multiplication and division, and it was basic math. And I was like, I know I'm not that far off. But I went back to physics the following semester because I passed basic math, and it was the same thing. And I could not do the math in the book, but I could nail the lab. I understood it. I understood physics. I just couldn't do the math. And for some reason, he ended up swinging the whole class and physics too, because like not one person got higher than like a 60 in that class.
Yeah.
And then all of a sudden I end up with like a B plus or something. But the it's just the way like it's always been the way I've operated. It's just if I do it, I can I can get it done. But the moment I'm trying to on my own like understand a mathematical problem in a book, it's like forget it.
Yeah.
So
I just one of the things that when we hire engineers and scientists here at Andersen, you hit exactly on one of the. We're trying to. There's a certain amount of like I don't know street smarts or like
Yeah,
just
right.
or we use the term farm physics sometimes, like just understanding how things work.
Yeah.
That's a huge component, but you also have the science and engineering understanding behind it.
Or I'd
Some
be
of our most
terrible
successful
in your role.
engineers and designers are the people that can do some of both, and
Yeah.
yeah,
it's incredible.
I mean, yeah, like you said, your comment about building cars and stuff like that, working on cars. That's all I did growing up. I built cars, worked on motors, rebuilt transmission. Like I understand, it wasn't even something that I understood. It just I did it.
Yeah, you just got it.
It
Yeah.
wasn't yeah, it wasn't like I pulled it apart and it was like, "Yeah, the viscosity of the fluid makes this go in from 1st gear to 2nd gear." It's like,
Yeah, yeah.
no, that I just understand that that needs to go there and this needs to go there and that should be clean and, and let's move on and get this thing back in the car.
It's even the engineers that we deal with in residential where it's like you have to you deal with an engineer who's just by the book on paper. What does the math look like? And everything's going to be extremely overbuilt. Where like you get an engineer who understands what's going on and how the building works. And it's like, yeah, you don't need to put twice as much lumber in that ceiling with $800 worth of hardware. It's going to be okay with this. And it's that like you said, the farm physics of it and understanding how a building comes together, how these systems work, how the materials work, and not necessarily relying just on the mathematics of it.
Yeah.
What when you first started with like 3M and Andersen, were you more boots on the ground, or were you like obviously at this point in your career you're managing a lot of people and overseeing a lot? Were you more like honed in on the engineering side of things when you first started?
Yeah, my first several years at 3M, I was doing different engineering work, working in manufacturing plants, working in labs, trying to optimize current products and develop new products. Kind of always found myself in leadership kinds of spots, even as an engineer. Um, but I don't know. I get a lot of I coach a lot of sports with my kids when they're younger. I just get a lot out of I really enjoy working with teams and trying to figure out um, how can you get a group of people to go achieve something they didn't think was possible or do it in a faster amount of time or cheaper, whatever that might be. I just get a lot of energy out of that, and I think it's fun to try to figure out um, what are people motivated by, how do they, everyone has a little bit different thing that they would love to be able to accomplish in life, and I just always have found myself kind of gravitating towards that kind of role. And even today in the role I have today, there's a lot of it is around coaching people to try to figure out how do you navigate, the different conflicts with the team or conflicts with we work a lot with the manufacturing team, and I love that team, but we are in conflict a little bit where we're trying to make changes and they're trying to not, right? And they're trying to keep producing the products that we make today, and we're trying to make some changes to it. So there's a lot of opportunities to try to figure out how do you navigate through that. And I get a lot of energy out of that, trying to figure out how to do that. And then over the next,
How did you learn? Like, was that all taught? Did the companies you work with train you to be able to do that, or was that like learned behavior that was a natural progression?
I think it's learned behavior, and I can name off several people uh, that I learned from and respected how they did that, both at 3M and Andersen here. And it's about having absolute respect for everyone's point of view,
Yeah,
and that's one of the you learn that like in Andersen, you walk the plant floor, the people that are doing that job every single day, uh, they have ultimately have all the knowledge about how these things what's actually happening on the plant floor. And if you understand that and you combine that with some of the engineering and science that we have, and you bring it all together, it's amazing. I mean, there are so many things that we've done here in the 10 years I've been here where we have a really good idea in R&D, and we've tested it as durable. You get into manufacturing, and when you listen to how things actually go together, you bring all that together, and that's how we make products that perform, that are durable at the scale we do. It's bringing all that together at the same time, and just really respecting everyone's point of view, and everyone has something to offer to the solution.
yeah. I feel like that a lot of engineers would really struggle with being in a role that you're in. And maybe that's like a stereotypical thing to say, but I feel that you have to, like, in your position, you have to adapt and concede and entertain so many different ideas and personalities and theories other than your own. And typically, like, the engineer mindset is like, no, this is what works. This is how it has to be done. and now you're like blending all of these different things together. And I feel that would be a struggle for most people with your background.
Yeah. Yeah. Well, there's definitely times where, um, I have a really strong opinion about a certain direction we should go. But we do things here that are really, we have a couple things we do that are really cool. So like we have a gate process when we develop a product or we make changes. And at certain gates, we call it a technical review, and we bring all the technical expertise we have in the company for like 30 minutes to an hour on a
Just
particular.
lock them in a
I
room.
mean, literally, like, just let them. And what's really, you got to, this is what I've learned to do. You got to create the right environment so people are comfortable, debating each other and maybe have conflicting points of view. We put them in a room and don't let them out until they come up with a solution. But
Whoever comes out alive
yeah,
wins.
whoever comes out alive wins. Yeah. But I mean, that's a good example. Like, you get everyone. It's very empowering. I mean, people. And by the way, it's not just engineers and scientists. It's the people that are installing product every day on the test wall that you saw, or the ones that are running the water tests that you saw. I mean, everyone gets involved to come up with the best solution, and I just get a lot of energy out of watching that. And I don't know, the team we have here. I would take on anyone in the industry and try to and compete with them. There's a lot of engineering and science horsepower here at our company that I'm just proud to be a part of it and try to direct it in the right way. Yeah.
Yeah, that I know that we're wrapping things up here, and I feel that that's a really good summary of how we started this. Where you think of Andersen Windows and Doors as this manufacturing company, and that they produce a product, but then when you really see how many teams are involved and how many different moving parts and how much management on like multiple layers that overlap and blend together to be able to put a window or a door to market, it is crazy. Like when we sat down, we spoke with Chris Galvin, and just like what his role is and how many people he's in charge of it and what's important to him and what he focuses on a day-to-day basis, and then to think how that's supposed to trickle down to the people on the floor. Like there's a lot going on and a lot of moving parts, and it's impressive to see everything that comes together to be able to create a window or a door. You don't realize that, and most consumers probably don't when they're shopping for windows or looking at window and door brands, but how much actually goes into producing a window and door is impressive.
Yeah, I couldn't agree more. It's actually some of the challenges that are here on the design is there's a lot of other products out there you could work on, a lot of industries and things, but the demands on our products, and then to do everything made to order, where everything we make is to have a special, unique size or feature or whatever option to it. It's quite a challenge, and as an engineer, it's energized to try to go after that and solve that.
Yeah,
I think that's the most, gratifying part of, at least my job as a custom home builder. It's, everything is everything is a brand new challenge. And it's not, you're taking what you've learned on the last prototype and figuring out how to apply it to this one, but you're still faced with a new challenge, or multiple challenges. And I think working through that and doing it as a team and quite literally sitting in a room and finding like bouncing ideas off each other. And usually when they're, like I said earlier, it's like when they're really wild ideas, it sparks this level of creativity that is really fun to work through.
Yeah, agree.
Well, Brandon, we appreciate your time. You know that you have a lot going on and limited time. So is there anything else that we didn't touch on that you would like to touch on or advocate for? Anything that you need to say before we hop off?
No, I think I got everything checked out. No, I'm kidding.
Cool.
Yeah, no, it's good. It was fun talking to you guys, and appreciate your time when you were here. And I got to watch all the videos that you guys shot, and it was fun to. Like I say, it's fun to have an outside perspective when you came in the plant. And again, I was very impressed with how insightful you guys were about even like the joinery that we're using and things like that. It was fun to watch those videos. So thank you for all that.
Yeah, hopefully next time they let us drive the golf carts.
Yeah,
up on the roof.
If you come visit again, I was gonna say I'll bring you up on the roof.
There we go.
All
All right.
Yeah.
Brandon, thank you so much.
Yeah. Thanks, guys.
And if you guys haven't caught those videos, head over to the Modern Craftsman YouTube channel. We posted all those videos up there. You can check them out. You definitely have to watch us fire a 2x4 at that glass window that we were talking about. And also, I think it's in the video. My brand new white Vans got red dye on them, and I'm looking down at them, and I'm still wearing the same pair.
Bomber. It's still on there?
Yeah,
That's good dye.
it's a good dye. You know what I should have done is I should have just dyed the entire thing.
The rest of them?
I could have had pink Vans.
Could have. That reminds me, I need to get new red Vans. Mine are all shot.
Wow.
Maybe Santa Claus will treat me.
Oh, there you go. I'll let Santa Claus know for you.
Yeah, well, as always, thanks for everything to Andersen Windows and Doors for everything that we do. Ellie, Brooke, the entire team over there helps us out a lot. Obviously, partners with us so that we're able to set some time aside and record this podcast. So we appreciate everything that you do. We'd be hard pressed to do this and continue to do this without the help of you guys. So we appreciate everything that you've done for us so far and everything that you continue to do for us. So if you are living under a rock and you don't know who they are, hop on their website, andersenwindows.com. That's ANDERSEN windows.com.
Yeah. And speaking of partnerships, head over to our website, moderncraftsman.co/shop. We partnered up with Hive Notebooks as well as Musgrave Pencils and Harnish Workwear. Unfortunately, the Harnish Workwear t-shirt has sold out, but we do have some Musgrave USA made #2 pencils and Hive Pro Notebooks, special edition, yellow and black from Modern Craftsman, up on the website for sale. So head over to our website and grab those. And we did get a bunch of messages about those t-shirts. I'm actually wearing version 1 right now. If you're watching this on YouTube, version 1 because I'm missing the modern. This just says Craftsman. But we might do another run. And we'll see you guys next week.
Thank you.